Welcome to Cybersecurity Under Pressure. Real attacks, real lessons. Every breach starts with something small. A trusted login, a missed alert, a system no one thought could matter. Here, we follow the incident. How it began, how it moved, what broke under pressure, and what security engineering and business teams should learn before the next one. Because the next attack will not wait for a perfect plan. Now, let's follow the evidence.
Welcome to Cybersecurity Under Pressure. Real attacks, real lessons. It is Friday, August 14th, 2026. And, before you close out your week and head into the weekend, there is an unresolved exposure and, a much deeper lesson that we really need to unpack for you today.
Yeah, we really do, because the stakes here are, they're getting incredibly physical.
Exactly. I mean, imagine an AI system that is so advanced it can route 400 trains an hour through Europe's busiest depot. It's avoiding collisions with millisecond precision. It's dynamically adjusting to track temperatures and passenger congestion.
Right.
Now imagine that exact highly classified algorithm just sitting there completely unprotected on some junior engineer's personal cloud drive over the weekend, just ripe for the picking.
Which is terrifying.
It is.
Yeah.
We are looking at a space where digital innovation is just colliding directly with heavy metal and critical infrastructure. So we really have to ask the central question. What are the current capabilities and limitations of AI in railway operations?
That is genuinely the defining question for the entire transport sector right now.
Right.
I mean, because the capabilities are accelerating vastly faster than our traditional trust boundaries can actually handle.
Right.
If you look at the evidence coming out of recent real-time intelligence events, specifically the one we just saw in Borlänge, Sweden, and, the steering of AI for transport resilience that was discussed extensively at the ITF Summit 2026, the shift in the landscape is just undeniable.
It's massive.
Yeah, we are no longer just talking about, predictive maintenance, like a sensor telling you a wheel bearing might fail next month.
Yeah.
Or natural language chatbots handling customer service ticketing. I mean, we are talking about Europe's rail-driving AI-based automated in-station train dispatching.
Wow.
We're looking at AI for safer and smarter depot operations and fully integrated infrastructure asset management systems. The intelligence it's moving out of the back office and directly into the operational nerve center.
Making the big calls.
Exactly. It's making real-time decisions that dictate the physical movement of thousands of tons of steel.
And, for you, the listener, navigating this space really means understanding what happens when those highly advanced, highly sensitive AI models crash into the gritty, highly fragmented reality of supply chain mechanics.
Yeah, the physical reality.
Right. These AI models aren't just software code living in a vacuum anymore. They are the new engineering assets. They literally dictate how physical trains move, how stations clear congestion, and how depot tracks are allocated to specific rolling stock.
Which makes them incredibly valuable targets.
Exactly. In our deep dive today, we are going to explore the massive friction between building these incredibly complex operational models and actually securing them when they, inevitably have to be shared across a decentralized global network of third-party contractors and lower-tier suppliers.
And, the attacker's perspective here is what makes this so critical to understand for you.
Right, because you look at it differently.
I do. As an attacker, I am not going to try to break into the primary railway operator's highly secured, heavily monitored, encrypted vault just to steal the master AI dispatching model.
Why not?
Because it's far too noisy. The cryptographic barriers are just too high, and the likelihood of triggering an automated defense response is, it's near certain.
Yeah, that makes sense.
So instead, I'm going to look for the weakest link in the physical supply chain. I'm going to wait for the exact moment that AI model is exported, converted into an engineering file format, and then handed down to a subcontractor who simply does not have the same multi-million-dollar security budget or infrastructure.
Wow.
We are dealing with a fundamental business challenge here. The conceptual power of AI is vastly outpacing our evidentiary controls over where that sensitive data actually lives and, who is manipulating it on their local machines.
Wait, so you're implying the system is almost designed to fail at the edges? Because, I mean, if the primary contractor literally cannot do their job without sharing the data down the line, then this exposure isn't some accidental oversight. It's like a strict engineering requirement.
That is exactly what it is.
Right, because the OT side of the house, the operational technology teams, they have to keep the trains running. You cannot build a smarter AI-driven depot if the prime contractor can't share the spatial layout and the AI algorithms with the actual people who are writing the code for the localized physical signaling systems.
It is a requirement, yes, but it is a requirement that is currently being met with a complete lack of verifiable telemetry.
Yeah.
I mean, the moment you share that asset down the supply chain, you create a blind spot. And attackers, well, they thrive in blind spots.
They absolutely do.
Technical breakdown.
Now let's move into the technical breakdown.
Yeah, this is where it gets really interesting.
Right. To really understand how this vulnerability materializes in the real world, we need to map the supply chain causal chain. Let's trace the journey of a single piece of data. We'll break down the 6-step technical mechanism of how a core engineering asset, say the master AI model for in-station dispatching, is handled and ultimately mishandled across organizational boundaries.
Okay, lay it out.
So step 1 is classification and the controlled repository. At the very top of the food chain, the primary railway operator does everything right.
The ideal scenario.
Exactly. Imagine a pristine digital vault. They take this highly sensitive AI asset, accurately classify it as critical infrastructure data, and they lock it inside a centralized encrypted repository.
Which is great, in theory.
Right. This isn't just a secure hard drive. It is an environment with strict identity access management, role-based permissions, and comprehensive immutable audit logs. Every single interaction is mathematically verified.
And from an attacker's perspective, and, well, from a defensive detection standpoint, step 1 is your baseline of absolute truth.
Right.
This is where you have the highest possible visibility. You're actively verifying classification labels against user roles. You are monitoring access control lists in real time.
So you see everything.
Everything. You're logging every single authorized export or read request. If a user suddenly tries to pull the entire terabyte-sized model or execute some unexpected API call, your security information and event management tools, your SIMs, they light up immediately.
Like a Christmas tree.
Exactly.
Yeah.
The evidence quality here is pristine. I cannot stress that enough. At step 1, you know exactly who did what, when, and from what device.
But you know, the railway cannot be built inside a digital vault.
Unfortunately not.
So we hit step 2, distribution to the prime contractor. Because the national railway operator doesn't pour the concrete, and they don't integrate the legacy track sensors themselves.
Right, they hire someone else to do the heavy lifting.
Exactly. They authorize a massive global prime contractor to handle the physical and digital integration. That prime contractor gets authenticated access to the repository to perform specific design tasks.
And here's where the trust boundary begins to stretch.
Yeah.
It hasn't broken yet, but the tension is introduced.
Yeah.
We still have detection opportunities at this stage, though. Because it is a Tier 1 prime contractor, we can usually enforce identity federation.
Right, so what does that look like?
Well, we can correlate the identity of the contractor's lead engineer, the specific managed device they are using, the exact file version they are accessing, and match all of that telemetry against the approved contractual purpose.
Okay, so we're still relatively safe.
We still have eyes on the glass, yes. We can see what they're doing because they are playing by the operator's enterprise IT rules.
Which brings us to step 3. Delegation to lower-tier suppliers. And this is where the pristine digital theory collides with engineering reality, and that trust boundary just fundamentally frays.
This is the breaking point.
Right. The prime contractor has to subcontract out highly specialized tasks. Let's say they need to customize the AI model's interaction with a legacy physical signaling protocol, something running on an ICS, an industrial control system, that was built in the late 1990s.
Which is incredibly common in rail.
Very common. So the task moves down the chain to a Tier 3 or Tier 4 supplier. Maybe it's a boutique acoustic engineering firm of 5 people in Germany who need to model the vibration of the new trains against the old station glass.
Right.
But here is the structural causality of the problem. These lower-tier suppliers are using tools licensing models, or network connectivity that are fundamentally incompatible with the primary operator's hyper-secure controlled environment. They just don't have the sophisticated API gateways.
Precisely. And the core issue isn't that the Tier 4 supplier is malicious.
No, not at all.
It's that the systems physically cannot speak the same cryptographic language. The AI model requires a continuous authenticated API handshake with a cloud environment to function.
Right.
But that 5-person Tier 4 supplier, they might be running a highly specialized, localized simulation tool that is deliberately air-gapped to prevent latency. Or it's built on an architecture that doesn't support modern identity federation like OAuth or SAML.
It's just a totally different world.
It really is. The compatibility just isn't there.
Yeah.
You are asking a modern cloud intelligence to interface directly with a closed-loop system designed 30 years ago.
Which forces step 4, export beyond the trust boundary. And this is the crux of the engineering dilemma.
Yeah.
Because trying to force these Tier 4 tools to operate inside the primary operator's hyper-secure enclave is, well, it's like trying to do delicate microscopic watch repair while wearing thick Kevlar gloves.
That's a great way to put it. You just can't feel the gears.
Exactly. The security environment is so rigid, so heavy, and so restrictive that the engineers physically cannot manipulate the tiny localized data points they need to do their jobs. The tools simply do not fit the environment.
So they have to take the gloves off.
They do. What
Yeah.
do the subcontractors do? They do what engineers are trained to do when they face a roadblock. They engineer a workaround to meet the deadline. They
Right.
export the content, they pull the AI logic, the spatial track layouts, the dispatching parameters, and they convert them. And they aren't just exporting a text file here.
No, these are massive files.
Huge. They are converting this intelligence into CAD files, computer-aided design, or massive BIM models. And for those not deep in the architecture world, a BIM file building information modeling isn't just a 3D picture of a train station.
Way more complex than that.
It is a massive, multi-layered relational database containing the physics of the materials, the spatial layout, the electrical grid, and the precise coordinates of the AI sensor nodes. It's incredibly heavy data. Or worse, they dump schematics into PDFs and just drop them into their own local, ungoverned collaboration platforms.
Which is an absolute nightmare for security.
The mechanism here is critical to understand. The very second that export translation happens, the original security controls, the encryption wrappers, the identity logging, the access expiration policies, all of it just vanishes. The data is stripped of its armor.
And that leads directly into step 5, which is peripheral exposure.
The vulnerability.
Exactly. Put yourself back in my shoes, thinking like an advanced persistent threat. I am entirely ignoring the railway operator.
Because they're too hard to hit.
Way too hard. I am targeting that Tier 4 supplier. Because now, those unprotected, armorless copies of the AI Depot operations model, which are embedded inside a 50-gigabyte BIM file, they are sitting on unmanaged endpoints.
Just out in the open.
Out in the open. They're sitting in a personal cloud storage account, like a consumer Dropbox, because the junior engineer wanted to render the physics simulation from their home desktop over the weekend to save some time.
Wow.
The attack surface has moved from a fortified digital bunker to a home Wi-Fi network.
That is wild.
And the attacker, they don't need a zero-day exploit. They just need to compromise a smart thermostat on that home network, pivot to the engineer's laptop, and steal the file using stolen credentials.
It's that easy.
It really is. The attacker gets the absolute crown jewels of the railway's future operational intelligence, and they did not have to bypass a single enterprise firewall, SIEM, or intrusion detection system to get it.
The Kevlar gloves come off and the watch gets stolen. And that leads to the final fatal step in the chain, delayed detection. Because the primary operator is completely functionally blind once that asset leaves the prime contractor's managed environment. They have zero telemetry.
Zero. The evidence trail just evaporates into the ether. You might have complex contractual agreements that state the Tier 4 supplier must maintain, industry standard security, but a contract is just a piece of paper in a drawer.
It doesn't actually stop anything.
It does not provide automated cryptographic alerts when an engineer syncs an unencrypted BIM file containing your proprietary AI routing data to an unsecured tablet. You lack receipts. You lack copy traceability. You lack deletion evidence.
Which means you don't even know you've been robbed.
The frightening reality is that an attacker could have that model for 6 months. They could spend half a year analyzing exactly how your automated in-station dispatching prioritizes train movements, looking for the specific ICS logic flaws to manipulate it.
Oh, wow. To cause a derailment or something?
Yes, exactly. To cause a derailment or a massive systemic gridlock. And you, as the primary operator, would have absolutely no idea it was even missing until the physical damage is actually done.
It is a cascading failure of visibility. I mean, you build this incredibly resilient, theoretically perfect, AI-driven dispatch system specifically designed to make the physical OT environment safer and more efficient. But the actual physical process of building and integrating it introduces a massive cyber-physical vulnerability through the back door of the supply chain.
Yeah.
We are essentially exporting our own vulnerability.
We really are.
Operational decisions.
Now let's turn to the operational decisions.
This is where the rubber meets the road.
It is. We have to translate these technical leakages into hard business and regulatory consequences, because the stakes here are no longer just theoretical IT problems.
Right, it's not just a computer glitch.
No. If an AI dispatch model or a smart depot layout is compromised, it is a direct hit to the operational integrity of the physical railway. The financial and reputational damage of a major rail disruption is staggering. I mean, we are talking millions of euros a day in economic impact.
Easily.
But beyond the immediate physical threat, you are now operating in a severely regulated landscape with genuine teeth. Let's look at the EU AI Act.
Okay.
This is the first comprehensive regulatory framework on AI, and under it, critical infrastructure transport algorithms absolutely qualify as high-risk systems.
Okay, so what does that mean practically?
It means you are legally obligated to maintain rigorous risk management and data governance. If your high-risk model is sitting on an unmanaged laptop, you are in direct violation.
Wow.
Then you have NIS2, the Network and Information Security Directive. NIS2 fundamentally changes the game by demanding stringent supply chain security and enforcing personal liability on management for negligence.
Personal liability.
Yes. It also introduces brutal incident reporting windows. You have to provide an early warning to the authorities within 24 hours of becoming aware of a significant incident.
And let's not forget the operational regulations specifically for rail. You have the new telematics applications, TSI, the technical specifications for interoperability, which is enforced by the ERA, the European Union Agency for Railways.
Right.
They mandate strict interoperability and security standards across European borders.
Exactly. And if you look at the focus of ENISA, the European Union Agency for Cybersecurity, their Cyber Europe 2026 exercise places its entire emphasis on collective response and supply chain resilience.
Which is exactly what we're talking about.
Precisely. They are explicitly modeling these exact cascading failure scenarios. The regulatory mandate is crystal clear here. You cannot defend your business and you cannot avoid massive fines and liability if you cannot cryptographically prove you have control over your engineering assets throughout their entire life cycle.
Okay, so what's the solution then?
Therefore, from a security and business defensibility standpoint, my position is uncompromising.
Uncompromising. Okay.
You cannot allow any unauthorized exports to Tier 3 or Tier 4 suppliers.
Wait, none?
None. The evidence clearly shows that the moment a file is converted to CAD or BIM and exported to an unmanaged environment, it must be considered compromised. Contractual governance is entirely insufficient.
I mean, a contract can't stop a file transfer.
Exactly. A PDF contract does not technically prevent someone from dragging and dropping a file to a USB drive. If we lack telemetry, if we cannot see exactly what the Tier 4 supplier is doing with that AI model at every given second, then we must technically halt the sharing. Zero export, period.
Okay, but
The regulatory exposure under NIS2 alone is far too high to rely on blind trust. We must implement technical controls that absolutely prohibit the data from leaving the monitored enclave.
okay, I hear the regulatory drums beating, and I fully understand the business risk you are laying out. But let's look at the operational reality on the ground here.
Okay, but the regulations...
We are talking about building the next generation of physical railway infrastructure. You cannot just mandate draconian absolute security controls from an ivory tower. If those controls fundamentally break the engineering workflows required to build the actual product.
If the workflow breaks security, it shouldn't exist.
But if you halt the sharing, you halt the project. It really is that simple. You are overstating the uncertainty, and frankly, you are delaying reasonable, progressive measures by demanding mathematical perfection.
It's not perfection, it's compliance.
But if you implement a strict zero export policy, what actually happens? The security tools will invariably be incompatible with a Tier 3 supplier's latency requirements, or, their highly specialized proprietary CAD software will literally crash when it tries to render a 50-gigabyte watermarked file while maintaining a persistent VPN connection to your secure enclave.
Then they need better software.
What do you think happens when the engineer's screen goes black for the 5th time in an hour?
What happens is they fail a security audit, and they are removed from the supply chain until they upgrade their systems to meet the baseline.
No, that is the theory. That is not reality. The reality is they will create shadow IT. Engineers are measured and compensated on operational continuity and meeting brutal project deadlines.
Whoa.
If you block their ability to work natively in the tools they have spent a decade mastering, they won't stop working. They will just find an informal, completely ungoverned channel to export the data anyway.
Which is exactly why we need hard blocks.
But they will bypass them. They will take screenshots, they will use unauthorized file transfer sites, they will run a script to strip the DRM. By locking it down too tightly, you don't actually eliminate the risk. You just push it further into the dark where you have even less visibility than before.
I see what you're saying.
But we have to design for operational resilience, and that means acknowledging the physical truth that some level of export is fundamentally required to integrate legacy OT systems with modern cloud AI. If you break the workflow, you break the security.
But how do you defend that compromise to a regulator?
By showing you have a balanced approach.
Imagine sitting across from an auditor from the ERA or an investigator examining a NIS2 violation. How do you explain that you knowingly allow the core logic for your automated in-station dispatching to sit on an unmanaged, unencrypted laptop just because you didn't want to inconvenience a subcontractor's workflow?
It's not about inconvenience, it's about physics.
The regulators do not care about the subcontractor's latency issues. They care that a critical infrastructure asset was left unguarded.
You defend it by showing that you applied proportionate risk-based controls rather than shattering the supply chain and halting a billion-euro infrastructure project. You show that you secured what mattered most and you monitored the rest.
Monitored how if it's exported?
I will concede that your point on total blindness is valid.
Thank you.
Blind trust in Tier 4 is reckless. We cannot just throw massive BIM models and raw AI parameters over the wall, cross our fingers, and hope the subcontractor's home Wi-Fi is secure. That is indefensible, I agree.
And looking at the reality of how these heavy industry projects operate, I will also concede that an absolute, mathematically perfect zero export policy across a 10,000-person supply chain is likely impossible if we actually want these AI-driven transport projects to be completed in this decade.
Right. It would just grind to a halt.
The friction would be too high.
So where does that leave us? Because we have two opposing forces here. We have the absolute necessity of data control and the absolute necessity of engineering execution. We need a convergence point. We need a defensible decision that balances both of these realities.
I believe the defensible decision is to adopt a strictly tiered model of asset management.
Okay, walk me through that.
We must brutally triage the data. We keep the most critical AI assets, the core algorithmic logic, the root cryptographic keys, the master dispatching models, the uncompiled source code strictly within the controlled enclave.
Real crown jewels.
Exactly. No exceptions, no exports, no matter how much the engineers complain. If they need to interact with that core logic, they must do it through a virtual desktop infrastructure that streams the pixels to them, but never transmits the underlying data.
Agreed. The crown jewels stay locked in the vault. And for the operational components, the localized spatial track layouts, the specific vibration integration parameters, the peripheral data that the Tier 3 and 4 suppliers actually need to run their localized physics simulations, we permit exceptional, limited, audited, and revocable exports.
Yes, but we don't just hand it over.
Right.
We permit it only when operations strictly require them, and only when the supplier can digitally prove a baseline level of endpoint hygiene.
Yeah.
We require them to use managed secure containers on their devices.
Exactly right. It becomes a risk-based exception process rather than a default free-for-all. We acknowledge that the trust boundary must occasionally be crossed, but we put heavily monitored toll booths on that boundary.
I like that analogy.
Right. We log who requested the export, the business justification, the exact file hash, and we embed time-to-live restrictions on the exported data where technologically feasible.
It bridges the gap. It balances the OT need for continuous physical production and integration with the enterprise need for regulatory defensibility and security.
Exactly.
Pressure test.
This brings us to the pressure test.
Let's put you, the listener, right in the middle of this theoretical framework and make it uncomfortably real.
Oh, this is the fun part.
Imagine you are the incident commander or the chief information security officer for a major national railway operator. You are facing an incomplete evidence situation. It is 10:00 p.m. on a Thursday night.
Okay, worst possible time.
Your threat intelligence team has just detected a strong suspicion, and this is based on a combination of dark web chatter mentioning your specific project codename and some highly anomalous login patterns failing against your outer perimeter of unauthorized copying of your brand new, highly classified AI dispatching model. And the intelligence points to the suspect being a third-party vendor deep in your supply chain. A Tier 4 acoustic engineering firm you barely know exists.
So way down the line.
Right, but here is the constraint. The actual technical scope of the leak is entirely unknown. You don't know if they stole a PDF schematic or the entire neural network. Furthermore, the third party's internal technical controls are a complete black box to you. You have no telemetry into their systems.
And the pressure is immense. The regulatory clock is ticking loudly.
Really loudly.
Under NIS2, if this is deemed a significant threat, you might have a 24-hour early warning window, closing fast. You have to notify the regulator by Friday night.
Yep.
At the same time, if you panic, pull the plug, and sever the prime contractor's access to halt the potential leak, you are going to massively disrupt the physical depot operations.
Because they need that access.
Right. That contractor is required to finalize the physical integration of the AI sensors by Sunday morning to allow trains to run on Monday. Halting production means trains don't move.
You are forced to make a decision right now, in the dark. You cannot wait for a 3-week, meticulously planned forensic investigation.
There's no time.
You must select an immediate, reversible, and traceable measure that decisively reduces the cyber risk without causing an unacceptable operational impact to the railway. You are staring at the dashboard. What is your move?
Okay, my immediate instinct, coming from the engineering resilience and OT side of the equation, is to focus on containment without breaking the continuity of the project. We cannot stop the trains.
But you have to stop the leak.
Right. But we need to preserve the logs, preserve the file versions, and establish a firm chain of custody immediately so that if we have to do forensics later, the evidence isn't destroyed.
Okay, how?
I would issue an immediate preservation order to both the prime contractor and the suspected Tier 3 or 4 vendor. Legally and technically, we lock down their environments from deletion. But we do not revoke their access completely. The engineering team must continue working safely on the depot layout so Monday's launch happens. Instead, we mandate that all ongoing work involving that data must happen within a strictly monitored recorded session, perhaps forcing them into a VDI, a virtual desktop infrastructure environment, immediately.
I understand the desire to keep the trains running, but preservation orders and VDI sessions for future work do absolutely nothing to mitigate the data that has already been exported.
Well, true, but
If the AI model or a massive BIM file containing it is already sitting on an unmanaged endpoint in that vendor's office, preserving the logs doesn't stop the bleeding. The attacker is actively exfiltrating it.
Okay, so what do?
I insist on far more aggressive containment. We must limit access duration immediately. We implement harsh session timeouts. If an engineer is idle for 3 minutes, the connection drops.
3 minutes is brutal.
It has to be. Furthermore, we must mandate the retroactive application of digital watermarking or data loss prevention tools, DLP, on any files that are currently sitting in their environment, wherever it is technically compatible with their CAB software. We need to tag the data so if it moves, we see it.
But that is exactly where theory completely ignores operational physics. Watermarking a massive, complex 50-gigabyte BIM file right in the middle of a live production cycle is going to introduce massive computational latency.
It's better than losing the file entirely.
You are asking their local machines to perform complex cryptographic hashing while simultaneously rendering 3D physics. It might literally crash the integration tools they're using to map the physical ICS sensors to the AI model.
I understand that.
But if their systems crash, they can't do the work. If they can't do the work, the depot doesn't open. You are causing the operational failure you're supposed to be preventing.
We have to accept that friction. The alternative is allowing a compromised vendor free rein over a critical infrastructure AI model while we wait and see. We push the DLP update, and if their systems crash, they reboot and deal with the latency.
I think you're underestimating the impact.
But beyond the technical controls, we must set a hard, undeniable review deadline. We tell the prime contractor to pass this message to the vendor. You have exactly 48 hours to provide cryptographic evidence of closure.
48 hours.
You must provide a certified forensic report proving the deletion of all unauthorized copies of the exported data, or we sever the connection entirely. Production halts on Saturday night if you don't comply.
Cryptographic evidence of deletion in 48 hours. From a Tier 4 acoustic engineering firm, they don't even know what that phrase means.
So they need to learn fast.
It's a 3-person shop running localized software. They don't have an enterprise forensics team on retainer. If you demand cryptographic evidence of deletion, they are just going to right-click, delete the shortcut on their desktop, empty the recycle bin, and send you an email saying, "It's gone, we promise."
Which is unacceptable.
Demanding enterprise-grade forensics from a boutique subcontractor in 48 hours is a fantasy. It's an impossible demand that just guarantees we have to shut them down.
Then they shouldn't be handling high-risk AI transport algorithms. If they cannot prove the hygiene of their environment, they are a systemic risk to the entire network.
So we just shut down the railway.
No, fine. I recognize the reality of their limitations. If cryptographic proof is impossible for them to generate, then we demand a signed attestation from their leadership backed by an immediate mandatory scan by our own incident response team using a lightweight agent deployed to their endpoints.
Okay, an agent.
If they refuse the agent, they are cut off. There's a reasonable compromise, it is reversible, it is traceable, and it forces visibility.
Okay, deploying a lightweight interrogation agent to their machines rather than expecting them to perform the forensics themselves, that is a reasonable, actionable compromise.
I think so.
It allows production to continue under heightened scrutiny while giving you the visibility you actually need.
Exactly.
But we need to establish clear, unambiguous escalation triggers. We cannot live in the state of heightened alert forever. If we implement these temporary measures, the mandatory monitoring, the limited access sessions, the DLP injection, and the endpoint agent, what specifically forces our hand to move to a full catastrophic shutdown of their access?
The trigger has to be based on the emergence of concrete new evidence. If our endpoint agent finds proof of unauthorized copying, moving laterally beyond that specific vendor's network, say jumping to a personal webmail account, that is an immediate trigger.
Boom, shut it down.
Shut it down. Or if we determine that the scope of the leakage involves the core AI decision-making algorithms, the actual neural network weights, rather than just the peripheral station spatial layouts, that is an immediate escalation to full revocation.
Because the risk is just too high at that point.
Exactly. The risk to the physical trains is too high.
Yeah.
Finally, if the vendor breaches their contractual obligation to allow our agent to run by the 48-hour deadline, we cut them off without hesitation.
That protocol makes sense. It allows the physical production to continue under extreme scrutiny, but it draws a firm, defensible line in the sand for the regulators.
Right.
But, as we unpack this, we also have to be brutally honest with ourselves, with the regulators, and with our business stakeholders about the residual risk here.
It's always there.
Even with all these decisive steps, even with the watermarking, the logging, the VDI sessions, and the deployment of endpoint agents, we have to acknowledge a terrifying truth.
Yeah.
An authorized copy of that AI model inside a standard engineering export might still have been captured on a personal device outside our direct control weeks before we noticed the anomalous login on Thursday night. We can mitigate the ongoing damage, we can stop the current bleeding, but we cannot unring the bell once that data crosses the technology boundary. If it was copied to a thumb drive last Tuesday, no endpoint agent deployed on Friday is going to find it. The exposure is permanent.
That is the harsh reality of the supply chain. Once the data leaves your enclave, your control is ultimately an illusion maintained by contracts and assumed compliance.
Key takeaways.
Finally, let's close with the key takeaways.
So we've covered a lot of ground today.
We have. But before we summarize the practical actions, I want to leave you, the listener, with a provocative thought to mull over during your weekend.
Oh, I like these.
We've spent this entire deep dive worrying about a Tier 4 supplier leaking the AI model to an attacker. We've focused entirely on data exfiltration.
Right.
But what if the attacker doesn't want to steal it?
Right. What do you mean?
What if, instead of taking the data out, they subtly alter the parameters of the track layout or the sensor calibration inside that unencrypted BIM file while it sits on that home Wi-Fi network?
Oh my God.
They change the structural tolerance by 2 millimeters. And then they just sit and let the junior engineer unknowingly sync a poisoned, physically dangerous model back up the chain past all your pristine defenses right into the main repository.
So they weaponize the file itself.
Exactly. The supply chain isn't just a vector for theft, it is a vector for injection. Think about the implications of that for a moment.
That is a chilling scenario, and it perfectly highlights why this requires a systemic solution. If we synthesize all of this discussion, there are very clear, immediate, practical actions you need to take within your organizations.
For sure.
For the technical, operational, and incident response teams listening, you have to design security architecture that respects the physical reality of the engineering job.
Yep.
You must integrate identity management, strict export controls, and granular logging directly into the actual engineering workflows from day one. And crucially, you have to rigorously test the latency and compatibility of your enterprise security tools with the subcontractor's actual CAD, BIM, and legacy simulation software before you mandate a control. Because if your security breaks their tools, they will bypass your security. It is human nature and engineering reality.
And for the security, risk, and business leaders, you must proactively and ruthlessly define which AI assets are the absolute crown jewels that must never, ever leave your controlled environment under any circumstances.
You have to know what matters most.
You have to establish clear, pre-approved, risk-based exception criteria for when peripheral data can be exported. You must assign definitive risk ownership to those decisions, and you must demand explicit technical audit rights that cascade all the way down through the Tier 3 and Tier 4 supply chain. Contracts aren't enough. You need the right to verify.
Ultimately, we can see that railway AI is moving from concept toward operational decision support, and our security models have to move with it.
Absolutely. The tension between building the automated future and physically securing it is where the real difficult work happens every single day. Thanks for listening to Cybersecurity Under Pressure. Real attacks, real lessons. We hope you have a great weekend, and we'll be back with a new deep dive next week.
You have been listening to Cybersecurity Under Pressure. Real attacks, real lessons. Real incidents leave real lessons. Stay prepared. Stay critical. And keep following the evidence.